the industry's going. The way the industry's going is to do network attacks these days to get footholds on the network. So here's the scenario where this would be useful. You are on an internal penetration test. You don't have Active Directory credentials, but you want them, and you're stymied because they don't have any vulnerable Jenkins servers or old servers that you can exploit, and then Mimikatz or do what you need to. So I wrote Icebreaker to make it much faster to perform a whole bunch of network attacks at the same time, not at the same time, but sequentially and asynchronously, so that you can get Active Directory credentials much faster than before. So my name is Dan McInerney. I'm a senior penetration tester and red teamer and researcher at Coalfire Labs over in Colorado. So what we're going to do in Icebreaker is it's a simple Python script. You can just git clone it. And it does 5 different attacks. It does RID cycling to reverse brute force, SCF file upload, LLMNR and MDT-NS poisoning, net NTLM version 2 relay, and IPv6 DNS poisoning in that order. It's very easy to set up. You can just clone it. Then you run the setup script once you're inside the directory. Then you set up a virtual environment. So I don't really want to install a lot of Python libraries system-wide because that can kind of mess things up, especially with Impacket. If you install Impacket through APT in Kali, for instance, and then you install it through pip, then you'll just have a nightmare headache on your hands. So you're going to use pipenv to create a little Python virtual environment that you can install requirements to. Pipenv shell just kicks off the virtual environment, and then you can just run Icebreaker exactly like that. Icebreaker.py-L is for a list of targets. You can also give it an XML document, so you can do an Nmap scan and then give it the XML output from the Nmap scan. In this case, this is going to be the simplest usage. You just have a text list of CIDR address ranges or IP addresses. It's mostly just glue between known attacks. This is not, there are no novel techniques inside of Icebreaker. It just makes the workflow that I've been doing for the last year or two way faster. I'm not going to go into a lot of the code, but this is kind of the basis of the script. We're using subprocess.popen, which is a library for Python that lets you run system commands on the machine. So attack number 1, let's talk about RID cycling. The RID is the number at the end of the SID. It starts at 500, that's the local administrator, and it goes all the way up to an infinite amount, whatever you have, however many users you have. So what you can do is cycle through these RID numbers. If you have a null SMB session, those are not enabled by default anymore. They used to be enabled by default, I think back in the Windows Server 2000 and a little bit past that. It's not enabled by default anymore. However, I still see null sessions on, I'd say, the majority of penetration tests. So if you have a null session, that means you can connect over SMB with no username, no password. Then you can just cycle all those RID numbers and get valid usernames. The reason we're doing that is so we can do a reverse brute force. A normal brute force is when you have one user and you have 1,000 passwords, and you're chucking all those passwords at that one user. The problem with that is that you lock the accounts out by default in Active Directory. By default, I think you get something like 3 to 5 password attempts per username before they get locked out. So I don't want to get locked out. And also, there are 2 passwords that I have noticed very specifically that are in almost every company's Active Directory environment. It's someone's password. Those passwords are a password with an @ and a 0, and the other one is season and year. The reason that obviously password is common because it fits all the default Active Directory requirements, which require 3 out of 5 rules, uppercase, lowercase, symbol, number, and then whatever the hell the rest of them are. The second one is so common because by default Active Directory, if not configured separately, will require you to update your password every 90 to 180 days. And that's essentially, it makes a less of a cognitive load on the user to just cycle their passwords by the season at that point. So they're going to say, winter 2018. Oh, I had to change my password again. Stupid Active Directory. Fine, summer 2018. And they just keep doing that. These 2 passwords are wildly efficient for getting a foothold in the network. It's absurd how common these are. So what you need is a nice long list of usernames, and then you just throw 2 passwords at them. Within that long list of usernames, someone is going to have one of these passwords, depending on how many usernames you get. So you can also use a custom password list if you're doing this attack with Icebreaker using the -p. This is what it looks like when you're running it. So I'm using RPC client here to do the username enumeration, to check if there's a null session. I do know that the username enumeration and the RID cycling has a new technique out. I think SensePost just came out with it a few months ago. So I'm going to update this shortly to do the new username enumeration techniques. But this works quite well for now. I think the update just makes it slightly more accurate. But you can see it'll throw out a list of all of these usernames that it found, Dan, Dan.da, Icebreaker, Bob, Steve, whoever. And now it checks each one of those with both of those passwords. And it does this all asynchronously. Now, asynchronicity is essentially Python's answer to threading. You can thread things in Python, but you will never actually have true threading because of something called the GIL, which means that you're never actually running two processes at the exact same time. They're just kind of alternating along while they're doing work. Asynchronous means that there's no loop, and you give it a bunch of events. And whenever an event is triggered, it'll go try and do some kind of action. And while that action performs, the loop just continues on. So this is an example of concurrent programming, but not in parallel programming. But asynchronicity just makes everything so much faster. So we're going to basically test all of these at the same time, more or less. Second attack is one that I actually didn't know about for the longest time, and I was actually shocked to find out about this one. It's called an SCF Upload attack. I use a script called SMB enum shares from Nmap in order to find all of the anonymously writable shares on a network. So you have your little jump box in their internal network. You're kicking off the Nmap scan, or Icebreaker will kick it off for you. And you're going to look for any shares that have anonymously writable areas of them. And if they have that, what you can do is upload an SCF file. Saying SCF file is kind of redundant, like ATM machine. It's a shell command file. So you can upload an SCF. Now, SCF files are strange. I don't know why they exist. I've never seen them in use for any practical purposes, but they do simple things like open up Explorer to a certain path or something like that. Now, what you can do is add your IP address to this file under the icon file option, and then whenever anybody opens up the share, not opens up the file, but opens up the share, you get their NTLM hash, their net NTLM hash, I should say. So this is very strange. It's a shell, and then it says command equals 2. I don't know what that does. I really don't care that much. The most important thing is the icon file equals, because that's where your attacker IP is going to go. So as soon as they open that share, their computer is going to go search for that icon file on your computer. And you're going to say, hey, you got to authenticate before you could do that. And then they'll authenticate, and then you send them nothing because you're kind of a jerk. Taskbar, I don't know what that is. Command equals toggle desktop. I mean, and I'm at a loss. I really don't care about any of this except for the icon file. The icon file, I still am not sure why it does this. Like, what is the practical purpose that Windows created this command, this file type for, and why did they make it so that you just open a share and their net NTLM hash is sent to the attacker? In order to make this attack work, you have to have an SMB listener on your IP address. You can't just upload the file and then like magically your string just pops up with their net NTLM hash. You got to run a tool like Responder, or some of the in-packet tools. So you got to run like an SMB server first to catch that hash. This is what it looks like while Icebreaker is working on it. It'll look for the anonymously writable share. It'll find it. It'll attempt to write to it. After it attempts to write to it, it'll then read the anonymously writable share to make sure the file actually uploaded, and so on and so forth. It's going to be using the SMB client from in-packet to do a lot of this, because in-packet is just a magical library for interacting with Windows networking stuff. Now, once you get that net NTLM hash, you'll have to crack that. So the first attack is going to give you plain text password. It's going to be either winter 2018, fall 2018, or it's going to be password with an @ and 0. The second attack is going to get you a net NTLM hash, which you must crack before you can use. And I'll talk about the difference between passing those hashes versus relaying those hashes in a couple minutes. So attack number 3, attack 1 and 2, they go super fast. Attack 3 can linger. It'll linger by default for about 10 minutes. And it's going to be doing LLMNR, NBT-NS, and MDNS poisoning. Now, these are all multicast and broadcast-based protocols. LLMNR is enabled by default in Windows networks, which is, I just love it. I mean, vulnerable by default has to be the most beautiful words in the English language. So whenever you just set up an Active Directory environment with default everything, it is vulnerable to LLMNR attacks. So all we're going to do is run this tool called Responder, which sets up a rogue SMB server and then poisons responses in the LLMNR protocol. LLMNR and NBT-NS and MDNS, they're all essentially like DNS. They're telling other computers the host name and the IP address and how they connect up together. So LLMNR, though, has less security features than DNS. It implicitly trusts responses. That means if you send out a broadcast, you're just shouting across the network, hey, who has printer 1? And you're using LLMNR to do that. Whoever responds first is going to be the one that you say, oh, okay, well, yeah, I guess you said you were printer 1, so I'm going to go ahead and just trust that you are printer 1, and now I'm going to send you my credentials. This is an example of how this works. So the victim is going to send out an incorrect SMB share address. Well, maybe they'll do netuse//snare01. Snare01 doesn't exist. So the DNS server, which is the first IP address to hostname mapping protocol that an Active Directory network will use, DNS server will say, hey, that doesn't exist. And now it'll fall back to LLMNR or NBT-NS. By default, it'll fall back to LLMNR. Now it sends out, it just shouts at the whole network, where is Snare01? And you, as the attacker, running responder, say, I'm Snare01, connect to me. And then that person, the victim, says, okay, great. I have no way of verifying this, so I might as well just trust it, sends you the credentials. This is what it looks like in action. So it's running responder for attack 3. And the beauty of this is that Icebreaker will actually auto-crack your passwords for you. By default, it'll only attempt to crack 10 passwords at a time, so you're not overloading your system. It's using John the Ripper. So whenever it gets a password from, or a net NTLM hash from responder, for instance, it'll automatically try and crack it. Now, it's cracking it with a very custom word list that I created. I went to the SecList's GitHub account, and I found a list of passwords. I think it was 34 million passwords or something altogether that they had listed there. And I sorted them out by passwords and eliminated all the passwords that don't fit default Active Directory policy requirements, which is 3 out of the 5 of those password rules, uppercase, lowercase, symbol, and so on. So that means nothing in my password list is going to have all numbers. Nothing in my password list is going to be nothing but all capitals and things like that. It's only going to be passwords that work in Active Directory environments, because this is an Active Directory attack tool for getting a foothold inside of Active Directory. So once it started to crack that, I removed, I want to say like 33 million of the 34 million. So now we're just left with 1 million common passwords that work with Active Directory. And you can see at the bottom here, it says password found, lab Bob, and the password is password. That's not because it actually got a plain text password. That's because John the Ripper cracked the net NTLM hash that responder gave it. So you don't even have to worry about hash cracking unless they have a very complex password. But the goal here is to get the low-hanging fruit fast so you can get into that Active Directory environment quickly and then start doing the cool stuff like the PowerSploit and the PowerShell attacks and the C# attacks, Bloodhound and what have you. Attack number 4 is my favorite. This is NTLM relay. Now, relaying a hash is different than passing a hash. You can only relay a hash once. Passing a hash is what you would do with an NTLM hash, which is what is stored on the computer itself. The net NTLM hash is a challenge response protocol, so you'll either have to crack it or you will have to relay it one time to a specific machine. We're going to use Impacket to do this again, because Impacket is, again, just a god of a library for interacting with these kind of things. An NTLM hash is above, a net NTLM hash is below. Almost everything you're going to capture is going to be net NTLM hashes. They don't really send, Windows networks don't really send the NTLM hash across the network anymore because of issues with passing the hash and things. This is sort of a breakdown of what a net NTLM hash is. It's the username, it's the domain, it's the challenge and the response, and the LM hash, and then finally the net NTLM hash is the last one, the NTLM hash. Although this is a bit confusing because that's not actually the NTLM hash as we see it here. This is a challenge response hash. So you can't pass this one either. You can just relay it. Now, the current state of pass the hash is actually kind of interesting. I think it's a little interesting side note. Microsoft has released a patch that they called the pass the hash patch or something of that nature, which freaked out all those pen testers because passing the hash is something that we all do on a daily basis. It's very useful. What Microsoft didn't tell us was that they didn't really patch it. They just kind of made it a little more difficult. So now, by default, you can only pass the hash of a RID 500 account. A RID 500 account is the built-in local administrator when you create the machine and the operating system. It's going to be, it's usually just going to be called administrator. Now, you can set other users to be passable, but you have to give them specific permissions and stuff. But this is fine because, you know, if you get onto a box and you're an administrator and you dump all the hashes, you can just take the RID 500 hash on that box and then just pass it around the network. So there's a lot more information about this on Harmjoy's blog. I have a link here. It's too small to read, but these slides will be public, so you can check that out. NTLM obviously can't be passed because it's not just a hash of the password, it's a challenge response. So the server's sending a challenge, the client is encoding or encrypting that challenge with the NTLM hash password of the user, and then it's getting passed back. So it's going to be different every time the NTLM hash is sent across the network. Now the NTLM relay attack is fascinating. This is what it does. So we have the client on the left side and we have the attacker in the middle. The client's going to say, I want to connect to that server over there. And the attacker is going to take that. We're going to man in the middle of their connection. We're going to take their authentication attempt, and we're going to negotiate the authentication with the server over there. The server's going to send the challenge. Attacker's going to forward the challenge like normal, just keeping the traffic as normal. Going to send it over to the client. The client's going to sign that challenge with their own NTLM password hash, and then pass it back to the server. Now the attacker here is going to just, again, pass that signed challenge back to the server, and the server is going to say, that's fine, this is all good and go, you're good to go, you can run commands on me if you're a local administrator. However, when it sends that okay, it sends the yes, you're allowed to do things to me, attacker's going to say, oh great, that's fantastic, but he's not going to send that okay to the victim. The victim's going to get an oops, I'm sorry, you couldn't do that. And then the attacker is going to go ahead and use that authenticated okay to do whatever he wants on the server. Now I find this attack to be incredibly useful. I find this to be effective and fast. There's a few caveats, one being SMB signing has to be disabled. Now SMB signing I don't think is disabled by default in Windows 10 anymore, it used to be. However, there are excellent reasons that system administrators disable SMB signing. And the reason is because it comes with a 15% network latency. You're going to slow down your traffic when you enable SMB signing. So a lot of administrators are just going to disable it. I find I'm going to guess over the past 3 or 4 years, about 75% of the clients I've been on their internal network have SMB signing disabled on some or most of their network. So I find this still to be an incredibly useful attack. Now the actual command that's going to be running, you can see here, it's the purple code there under text command equals. It's going to add an administrative user. It's then going to add, it's going to download the invoke Mimikatz PS1 script through an IEX cradle. It's going to run Mimikatz. And now I have also included these Mimikatz scripts and this power dump script that it also runs with heavy obfuscation within the Icebreaker folder. So I've done invoke obfuscation to make sure it passes Windows Defender. I've done an AMSI bypass at the top of it. So it should be just fine to pass Windows Defender as of today and as of tomorrow. There was a little update in Windows that recently broke that, but I just fixed that this morning, so it should be good to go. So what it's going to do is run PowerShell, exec bypass, no profile, and a hidden window. So nothing's going to pop up for the user or anything. So adds administrative user, runs an obfuscated Mimikatz, an AMSI bypassing Mimikatz, and then an obfuscated and AMSI bypassing invoke power dump. Invoke power dump just dumps the hashes. Mimikatz dumps the plain text credentials. Now the final attack it's going to do is the IPv6 DNS poisoning, which if you were in this track right before, we were actually talking about. It's going to use the MITM6 tool by Fox IT, which is going to essentially say that it's a DHCP, an IPv6 DNS server. I'm sorry, DHCP server. Again, I'm sorry, it's a DNS server. Now, since Vista, every Windows network by default requests IPv6 DHCP servers at regular intervals, which is, again, fantastic for us because we can just run this MITM6 tool and it will pretend to be an IPv6 server. Now, as soon as a computer connects to it, it's going to respond and say that the attacker's machine is the IPv6 DNS server. So now all DNS requests are going to go through the attacker's machine. And another beauty of Windows networks is IPv6 is preferred by default to IPv4. So it's just going to override default network settings. Now, this is an interesting tool because it actually bypasses another Microsoft patch that was supposed to make our lives harder. And that patch was when they fixed the WPAD. Windows proxy auto detection. Now, in the past several years, you've been able to send up a spoofed WPAD server. Whenever a Windows server spins up or tries to connect to something on the internet, it'll often send out a request looking for wpad.the Active Directory domain. Now, in the past, you could just spoof the WPAD DNS entry. You could say that I'm wpad.whatever, and whenever someone connects to you, you say, you can't have WPAD proxy settings just yet. You're going to need to authenticate to me. So Microsoft patched that. Now you cannot be a rogue WPAD server and say, you can't have the proxy settings unless you authenticate to me. It doesn't work that way. So what they did to get around that was now they just give you the proxy server. So you spin up a fake WPAD proxy, the machines on the network connect to you, and then you give them valid proxy settings. You give them the actual valid proxy settings that say you are the proxy to the internet. Now once that machine connects to you and sends out any request to the internet as a whole, then man-in-the-middle 6 will say, I need your authentication before that you can access google.com or msn.com or what have you. And that's how it gets by that little Microsoft patch. You know, it's just such a cat and mouse game we have here. But this is a beautiful way of getting net NTLM version 2 hashes. It also is very dangerous. So I will say I have used this on client engagements. I suggest if you're going to use this IP version 6 attack 5, and you can skip any of the attacks we've talked about with Icebreaker. You just use the -S flag to skip any of them. If you're going to run Icebreaker for an extended period of time, you don't want to run this one because it breaks stuff. You're taking like essentially the whole network and trying to shovel it through your tiny little pipeline, and you're going to have a lot of problems, especially with Exchange, I've noticed. Exchange does not like man-in-the-middle 6, this tool whatsoever. So when I run Icebreaker, what I usually do is run it by default, and I'll let it run for about maybe 10 minutes. Just enough time so that if anybody notices something's broken or their mail isn't updating or anything, then you just shut it down, and within 10 minutes they'll be good to go. And they won't really think that much of it. But skip this one if you don't want to cause any trouble on the network. If the client's like, listen, my network, it sucks, it's terrible, I don't want you breaking anything, skip this one. The final option for Icebreaker is the auto domain option, auto domain admin. So if you do the -- auto flag on here, and then either tmux or xterm, it'll open up Empire and Death Star, and as soon as Empire gets a shell, which Icebreaker will give it shells through NTLM relay, then Death Star will take over and start attacking using that shell on Empire. So this is essentially a method of hitting enter and then waiting for a net NTLM hash to come in that you can relay, and then once it relays it, Icebreaker will send the Empire stager to the computer, you get a shell, Death Star takes over and goes straight to domain admin. It's just a one-click domain admin. Death Star I don't think is maintained that much by Marcello anymore. Marcello is one of my closest friends. Marcello Salvati. Byte Bleeder is how everyone knows him. He wrote Crackmap Exec as well. I don't think he maintains Death Star that much, so I ended up taking over that project a little bit and maintaining it just enough so it works with Icebreaker, and I just have it pegged to the versions that work, the Empire version that works and the Death Star version that works, because Empire 2 is a nightmare to deal with their API. Their API changes like every week, every couple days. It's a real hassle to keep anything up to date that uses the Empire API. So I have those just pegged, no problems. Xterm is if you want to have a little window pop up and then watch it all run through in the window. Tmux is if you don't have a graphical environment, you just have a text environment, then you can just open a Tmux window and it'll kick off all of this auto domain stuff in that little Tmux window. All right, so I'm going to do a little live demo here. See how much time I have. Oh, almost nothing. So real quick. We are going to log in. And log in. And we're already logged in here. Okay, so on the Kali machine, we've done the target file. Target file just has my other IP addresses. We have a server, Windows 8 computer, and a Windows 10 computer. So we're just going to run Icebreaker real quick. It's going to nmap it for you. It's going to do all the NSC scripts. It's going to find a bunch of open ports. Okay, great. 445 is open. Found a domain controller. We're going to do RID cycling. We found a null session on the domain controller, found all these usernames, and now we're going to reverse brute force. But it actually did find passwords for that reverse brute force, but I have, in my settings, I have found passwords Move found passwords. There we go. It did attack 1 really quick. It does attack 2 really quick. We're going to skip attack 3 and go straight to attack 4. See, now it's found some passwords. Password in fall 2018. We found a password from responder logs. We're going to kill responder, and now we'll do NTLM relay, and then I'll get off the stage. So we're going to kick off a little SMB traffic. And the way we're going to do that is open up Internet Explorer. And we're going to accidentally type http:// Google. But we're going to leave off the .com. Just do Google. And that sends some SMB traffic. Oh, and it says the page couldn't be found, but we see here. See if I can zoom in for you. Of course I can't. We see we captured the NTLM hash, net NTLM hash. Now John the Ripper is running right here to crack that hash. And we are relaying that hash to the server, and we're going to run Mimikatz, power dump, and add an administrative user. If it takes longer than about 10 or 15 more seconds, I'm just going to get off stage because my time's up. There we go. User created. Status sharing violation is a common error in NTLM Relay X. I assume they're going to fix that at some point in the future, but if you just redo the SMB traffic, it'll usually work on the second try. So that's what it looks like. It will print out all the plain text passwords and the hashes that it dumps when it doesn't get the status sharing violation. All right, thank you very much.